Next video here in kind of reviewing and crash course for Taylor series and all that stuff. In the most recent video, we sort of talked about what a Taylor series was, or at least the formula, and how it differed from a Maclaurin series. The Maclaurin series is just a subcategory of a Taylor series where instead of x equals a, we got x equals 0. And we were given this little thing right here. We found the polynomial, and then we used it to approximate f of 0.3. The next question is really similar. This is an actual Taylor series question. It couldn't fall into the Maclaurin subcategory, but it says it's really similar. It says f is a function, derivatives, blah blah blah. Assume that, all right, f of 1 is 5, f prime of 1 is -3. And f double prime of 1 is 1, and then f triple prime at 1 is 4. Now, we want to write the third degree Taylor polynomial and then use it to approximate f at 1.2. So we're not going to use this formula. Instead, we're going to use this one up here. You can see I copied it and pasted it so we'd have it right here in front of us. And I'll go ahead and do the problem. We'll do it in purple. All right, so, oh, and let me address something. It said third degree Taylor polynomial. What do you think we would answer if it asked for the second degree Taylor polynomial? Well, this is the cubed part, so we wouldn't include the cubed part. If it asked for the fourth degree Taylor polynomial, well, we would need to have the fourth derivative as well in order to get that information. All right, so here we go. T is equal to, all right, I'll write a equals 1 because we were doing it about x equals 1. So everywhere there's an a, I'm going to let it be 1. So the first thing it says is f of a. So f of 1 is 5. So I'm going to write 5 plus f prime of a. F prime of 1 is -3. So I'll just write -3. And then times x minus 1. This is where this one's different from the previous one that had x minus zeros or just x's. And so far, this would actually just be the tangent line. And then, all right, so plus f double prime of 1, well, that's 1. So 1 over 2 factorial is just 1 over 2 times x minus 1 squared. And then plus f triple prime of 1, which is 4 over 3 factorial times x minus 1 cubed. All right, let's do the 4 over 3 factorial. 4 over 3 factorial, so 3 times 2 times 1. Which I can divide the 2. Well, I like to divide this into that and make it a 2. So that's 2 over 3. Did I do that right? I think I did. So we're going to write t equals 5 minus 3. And we're going to leave it as x minus 1. We're not going to distribute or anything. Plus 1/2 times x minus 1 squared plus 2/3 times x minus 1 cubed. So that is the third degree polynomial. Now we want to use it to approximate f of 1.2. And just a little plug, a lot of times, like when we have a problem like an FRQ or something like that on AP test, they'll ask 2 questions in one, right? So we want to find the Taylor polynomial and then we want to use it. This could have been broken up into an A and a B, you know, just says A, whatever. All right, so I want to use it to approximate f of 1.2. So t of 1.2 is equal to 5 minus 3 times 1.2 minus 1. And you might see a pattern here. Plus 1/2 times 1.2 minus 1 squared plus 2/3 times 1.2 minus 1 cubed. The pattern that I see is that all of these parentheses have 1.2 minus 1. Well, they're all just going to be, and this is the way that these lines work a lot of the time. If I build it around 1 and then approximate it, usually I'm doing somewhere that's close to 1. 1.2 is close to 1. So that is equal to 5 minus 3 times 0.2 plus 1/2 times 0.2 squared plus 2/3 times 0.2 cubed. And this is where we go to a calculator, so we'll type it in. All right, so I plugged it in my calculator, and I got 4.425. That's 3 decimal places. It becomes a repeating decimal afterwards, so I'll bring one more and write the 3 with the little bar over it. All right, so hopefully you see how to do these types of problems when they ask us for either a Taylor or a Maclaurin series, given this kind of information. There's other ways that we can do Taylor and Maclaurin series, and we'll get into that in a little bit in the next question. The next question will be its own video, so I'll see you in that one. Peace, y'all.